Let's talk about matrix power. So as you know, if you have a matrix, let's say A equals whatever, let's say one, two, three elements. All right, and if you do A and you raise it to 2, do you think it will work? Okay, so A to the power 2 means it will mean it's like you multiplying A times A. But you know, in this case, will it work? Will it work? Remember the condition to multiply two matrices is to have uh, so this will be 1 times 3 times 3 and times 3, and it's multiplied by again 1 times 3. All right, so the number of columns in the first one does not equal to the number of rows in the first one, so this will give you an error. Let's try it. You see an error. Okay, if we multiply, for example, so that's a problem. All right, so raising a power, that means you're multiplying the matrix by itself twice. If you raise it to 3, for example, okay, that means you're multiplying the matrix by itself 3 times. And still, you have to meet the condition. You have to meet the condition. All right. So let's modify our matrix in here. All right. And let's say make it 2 rows, and the second row, which is 4, 5, 6, for example. So if you try to square it, will it work? Will it work? Of course not. Why? Because the first one, let's do it again. So that's like equal to multiplying um, a multiplying a. All right, a times a. Okay. All right. The first a is 2 times 3, and the second one is um, again 2 times 3. So the number of columns of the first matrix does not equal the number of rows for the second column, so it will not work again. It will not work again. All right. Let's make it like 3 by 3. Let's make this, for example, 7, 8, 9. So 9. Okay. So now this is like 3 by 3, 3 by 3, 3 by 3 matrix. So will you be able to square it? Of course, because the number of columns in the first matrix equals the number of rows in the second matrix. So this will work perfect. It should work perfectly. So let me remove all of these comments in here and try to run it, and you see A multiplied by itself, which is a 3 by 3 matrix, multiplied by a 3 by 3 matrix, will give you a 3 by 3 matrix, will give you a 3 by 3 matrix. Please note, this is completely different than doing it this way. If you do it like this way, all right, um, uh, 2, this one in here, it will square each element in the matrix. It's not matrix multiplication, it's like squaring each element. So let's run it in here. As you see in here, this is a matrix multiplication, this is matrix multiplication multiplication, and this is not a matrix multiplication. It just squares. This will do um, 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 squaring each term. So okay, so for example, 9 squared becomes 81, 8 squared becomes 64, 7 squared becomes 49, and so on and so forth. So they are completely different, completely um, different. All right, so also, um, if you raise the matrix to non-integer power, so let's try it, non-integer power. So for example, you have a, okay, to the power of 1.5. All right, so it will give you a complex result. Let's try it out. So it gave you the complex result. All right, so you have to be careful what you are doing. But anyways, raising to power is multiplying. There's two ways, to raising power. This is a matrix multiplication, and this is just squaring each term. You have to be careful with that.